on chapter 9. We need to do homework little bit by little bit. Homework is posted online already. Chapter 9, here we go, and we start. Sequences. Okay?
Yes.
Our calculator's ready, right? Let's read through one more time. A sequence. Wait, sequence. Do you remember what a sequence looks like from pre-cal? A sequence would look like A1, A2, A3, A4. Some are infinite, some are finite. Sequences just follow. It could be 1, 1, 2, 3, 5, 8. What's that? The Fibonacci sequence. It could be 1, 2, 4, 8, 16, 32. That could be a geometric sequence every time. Common ratio times 2, times 2, times 2. Sequence of terms, right? A sequence is said to converge. We saw this last chapter. Converge if the terms of the sequence eventually stabilize towards some single limiting value. Now, there's a lot of important stuff here, but stabilize. It could be fluctuating, but then it starts to stabilize towards some single limiting value. That means like a constant, right? Otherwise, we say the sequence diverges. Convergent behavior of a sequence in decimal form can be seen as more and more decimal places become fixed. This is like more of an experimental. As more and more decimal places become fixed. Meaning it could be 0.34, then 0.334, then 0.3334, and it starts to just stabilize, and then 0.333468. As they become more and more stabilized, then we can see that it's also as they become more and more fixed. This can take a long time though, so we can't always see it as easily as we would like. Here's a big note. If a function is bounded and monotonic, hold on, quick reminder, what's monotonic mean? One something. Strictly increasing or strictly decreasing? Let's do a quick reminder. Monotonic, strictly increasing or strictly decreasing. If a function is bounded and monotonic, then it must converge. If a sequence is convergent, then it must be bounded. The converse is not true, meaning if it is bounded, just because it's bounded does not mean it's convergent. If a sequence is convergent, it must be bounded. There must be a limit. But just because there's a limit does not mean that the sequence is convergent.
If the sequence is convergent, then must be bounded.
If a sequence is convergent, then it must be bounded. But if a sequence is not bounded, it's not necessarily not convergent. That sounds weird. We'll see it. Okay. Before we do any examples of sequences, we're building up to series, but we're not there yet, of sequences and just kind of discovering whether or not sequences converge. Just the terms, okay? First of all, we're going to use sequence mode in calculator. So in our calculator, if we go to the mode, I'm going to go and get my calculator up. We used, those of you that had me for pre-calculus, we used sequence mode a little bit, not tons though. And this is more for exploring, but you guys know in the AP sometimes you can use calculator, right? So it's good to know how to explore. If we go to mode and if we go to sequence mode, not function, not parametric, not polar, but sequence. Okay? If you go to your y equals, you see the following. You see n min, you see u of n, you see u of n min. And here's how you use it. Technically, let me rearrange this. That looks more like calculator. Hold on. This third one, I want to switch the order of. We'll do... This calculator shows u of n min. There we go. That looks more like calculator, right? There we go. So when I say n min, I mean the lower bound. Lower bound of what? I mean the lower bound of... What does n stand for? if a sub 1 is u of n min, a sub 1 is u of n min, and u of n is a sub n. Do you guys remember what n stands for in sequences? The number of
The one that you're looking
the nth
for?
term. Does that make sense? So n min, what I mean in n in all of this is that n itself, I'm talking about the nth term of the sequence. So it could be the first term. Okay, it's not first, second, third, fourth, fifth, sixth, 11th, 12th, 13th. All the rest are ths. So even though first, second, third is kind of weird, all the rest are nth terms of a sequence. Okay? So when you're seeing n, all along the way, it's talking about the nth term. And in sequences, in order to be able to use our calculators in sequences, if we can find a pattern and express that pattern, not recursively like times 2, times 2, times 2, times 2, but when n is 2, plug it in as function and you get the term. When n is 3, plug it in as function, you get the term. When n is 100, plug it in as function, you get a term. Way more practical than just seeing the pattern. So we're going to set our mode to sequence mode. We're going to establish n min as the lower bound, which we almost always start at the first term. Some people, some books, some mathematicians start at the 0 term. They call the first term the 0 term. That sometimes gets confusing. So usually we'll say the first term, n min is 1, the first term. And then u of n is going to be like our function for each term. Like our function for each term. And u of n min is going to be the first term itself. So this is going to be like the first term, a sub 1, the first term in the sequence. And then we're going to use our graph table to evaluate the functions. Wait, to evaluate what? Well, hold on, let's look. What are the problems going to look like? Alright guys. Are these sums? No. Why not? What's missing? In order to be a sum, in order to be term plus term plus term plus term plus term, shouldn't there be a big ol' sigma? Remember the sigma? There would be a big ol' sigma if it was a sum. It's not a sum. Not a sum, not a sum, not a sum. Let's write out just a few terms of this sequence. What would the terms be? First term, when n is 1. 1. Second term, not plus, just next one. 1 over 2, then 1 over 3, then 1 over 4, then etc., right?
So 0.
Investigate the following functions on your calculator. Determine whether the sequences converge or diverge. Now, sequences, hold on one more time. What's it take to converge or diverge? If the terms stabilize towards some limiting value, I can say the terms converge. The sequence converges, okay? So, Ethan already pointed out, you guys don't even need a calculator on this one, right? What's this one going to be doing?
Getting smaller.
Getting smaller and smaller and smaller and smaller. Is it bounded by something?
No. Infinity.
What can it never go beyond? 0, right? So therefore we could say this one is converging and converging to what?
0.
Converges to 0. Now, if only the whole chapter was this easy, we'd be awesome, right? Once again, we're not stopping at sequences, we're just starting there. We're trying to get to series, which is a whole other matter, because let me just give you a hint. This is where we're going, this is not where we are. One plus 1 half plus 1 third plus 1 fourth plus 1 fifth plus 1 sixth plus 1 seventh plus 1 eighth diverges. What? But the terms converge. But the series diverges. AKA it's not bounded. AKA I cannot say it equals a certain constant. Confusing. It's called the simple harmonic series. Anyway, calm. I erased it. We'll learn so much to help us to figure that out. Oh, sorry. How about this one? How about this one?
It doesn't have any enter.
Hold on. If we were to use our calculator, what would we do to use our calculator to help us analyze this? What would be our n min?
0.
0. That's our lower bound, right? So I plug in 0. What is the equation or the function for the terms of the sequence? Negative 1/2. But what did you guys notice is not there? Do you guys remember the cool trick I showed you? The little fraction? So you could do negative 1/2?
Oh wait, what's the trick?
Ooh,
Where's the trick?
that's fun. You can make little fractions in your calculator. It's alpha,
Oh, yeah.
alpha y equals. You can do little
I went to
fractions.
show that to you, Layla. You weren't there that day.
Do alpha,
Alpha.
y equals.
What?
There's a whole hidden menu. Ooh.
Oh.
Okay, anyway, sorry. Shh. Distracted. What's the first term? U n min is u of 0 is a of 0. What's the first one? Negative 1/2. Because that's the first one, right? So then I could go ahead and use the graph. I could look at the graph, but I'm just going to see point. But does that help? Kind of. Is it going anywhere?
No.
Nope. I could go look at my table and I could say, okay, when n equals, hold on. Let's go table setup. Well, we could do that, right? That's not a bad thing. I could do when n equals 1, when n equals 5, when n equals 50, when n equals 500. Oh, you know what it's doing right now, right? It's actually generating the sequence. Okay, what's it doing?
Convert A equals to.
Don't say equals to, but it is
Converges to 0.5.
converges to negative 1/2. It's not doing anything, right? Of course it has to converge. Converges to. Okay, let me give you a couple. You guys on your own. I'll check in a second. Let me zoom in. Sorry, kind of small. Youngji, can you see okay? Yeah. Do you have contacts today? Do you like them or no? Oh, you don't.
Contacts are really annoying at first.
I know my dad likes them, but friends really hate them.
I like them. I like them because I'm really bad with glasses. I always lose them.
Layla. And there's people like Layla who don't do either.
And just squint.
Yeah.
Okay,
When
keep
they
keep
drive.
squinting. Is it too
Yeah,
small?
but he's far away. Well,
Kind of.
it hurts.
Layla drives.
Layla's
without
squinting
her
too.
glasses. Layla drives without her glasses.
You guys already got answers?
No.
For both? You could look in your calculator, you could write out a few terms and think about it. Well, you guys.
I got it.
Yeah.
Phase E.
Wait, how do you do the sequence? I lost it already. I had it like 2 seconds ago.
See, on the thing where it says U and min, what are you supposed to do?
Lower bound. So I'm going from first to infinity. So first. And then I have my function. So I do 1 plus 1 over n.
To the end.
Ooh, I forgot that. Thank you.
How do you do it?
Oh, n is just like variable buttons. See how it can be x, but can be n in sequence mode. So it just naturally does what you want it to. And then first term is 1 plus 1 to the 1?
Yeah.
2, right? 1 plus 1 to the 1, 2.
Oh.
So if we were to see it, it would be 2, and it would be 3/2, 9/4, and then it would be 4/3, 16/9, and then it would be, what is this?
Like bounces.
does kind of bounce, huh? Like boing, 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 boing.
BC.
Huh.
I forgot where's the bounce mean.
What's the bounce mean? Oh, like a ball, like boing, 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 boing. That's bounce.
So if n equal to 0, where's n means?
When n equals 0, is that what you mean? No.
If n equal to 10, equal to 10.
If n equals to 10, 1.1. Because 1 and 1/10 would be 11 tenths, and 11 tenths to the 11th. Wait a minute, something's wrong. What's wrong with mine? Oh, I never put to the n. I knew something was wrong. I'm like, wait a minute, because that's 1 over, that's going to 0. Thank you, thank you, thank you. I was like, that's weird. I knew that wasn't right. Now let's try. There we go. Ooh, this looks interesting. Now we have to have get decimals start to being fixed, right? So we can go maybe to 50. Is that going to start getting any decimals fixed? Ooh, I have 2.6 fixed, right? Let's go to like 100. Is there anything else that's going to get fixed? 2.6.
It's around there.
2. It went to 2.7. Okay, hold on. Let's try 1,000.
9999.
I think it diverges. Just slowly.
No, it's not.
Just really slow.
It's e
How come, Ethan?
because it's the formula.
It's the formula. Did you already go ahead in chapter 9?
It's a formula. Not even.
And you didn't want to start it. Mm-hmm. So it's thinking because we're going to 1,000.
Almost 10,000.
You just check. I know. 2.7169. Wait a minute. 2.7169. 2.7169. 2.716. Ooh. It's going very, very slowly, but 2.71, and it's going to keep on getting closer and closer if we were to keep on going further and further. Now, this is one that you would be like, I don't know what it's going towards. 2.7 something, theoretically, right? Oh, this is going to take forever. I'm going to let that keep thinking as we come over here and as we say, this is why this isn't exploratory. But guys, there are going to be some formulas we need to memorize. But this does converge to E, which is interesting. -1 to the n. Did you guys get that one? What's that going to be? -1 to the 1. -1 squared. -1 to the 1. -1 squared. -1 to the 1.
Oh, that's fun.
Is it converging?
Yes.
Oh, no. What's it doing?
Oh,
Back,
it's
forth,
just
back, forth, back,
oscillating.
forth. It's like us. It can't make up its mind. So, diverging.
It's oscillating.
Does that make sense?
But why?
Because it goes back, forth, back, forth, back, forth.
No, but Miss D. Oh yeah.
Does that make sense?
Oh, dear, there's more.
All right, let's keep going. So we could use calculator, or we could just use
Our brains.
our brains, yeah. 3 squared.
Powers.
Guys, what's going on with him? Numbers are getting bigger. E to the power of is getting bigger. Who's getting bigger faster?
Low.
The bottom one, right? So if the bottom one's going to get bigger faster, is it going to keep on? 25 over e to the 5th?
So
36 over e to the 6th? 0. Converges to 0. Why?
You can use
Bottom wins.
you can use L'Hopital's, right?
Kind of. Mm-hmm.
You see the lowest ones n equal to 0 means
Means first one you plug in is 0.
we start from 0.
Yeah.
Um,
Yeah. And sometimes 1 is easier to make formula, because if I needed to start at 0, like say it was just 1 first, I would need to do n minus 1 squared and e to the n minus 1. Ugh, let's just start at 0 and do n squared over e to the n squared. Or e to the n. I guess that'd be 0, huh, not 1. How about this one? Sine of, start at 0, right?
I can't see.
Start at 0. Oh yeah, is going to be 1. No, sine of 0 is 0. You convinced me though. 0 pi over 3. Well, that's going to be 0. Next one, sine of 1 pi over 3. Can I just write it?
Square root of 2 over 2.
Sine of pi over 3?
Is
Square root of 3 over 2, right?
Square root of 3, yeah.
Then sine of 2 pi over 3. Square root of 3 over 2. Sine of 3 pi over 3. 0.
5.
Sine of 4 pi over 3. Negative root 3 over 2. Sine of 5 pi over 3. Negative root 3 over 2. What's it doing?
Diverging.
Diverging. It's divergent. Ha ha ha. Right? It's not going to converge. It's going to keep on cycling over and over and over and over. How about next one? 7.
Is that true with like all trig or is
Well, hold on. Let's see the next one. How about sine of n pi from 0 to infinity? Well, sine of 0. 0. Sine of 1 pi. 0. Sine of 2 pi. 0. 0. 0. The terms converge to 0, right?
Yeah, so it's 0.
But you're right, Melissa, that most trig alone, where it's not just 0, 0, 0, 0, is going to diverge. Most trig alone. That's not just like one term over and over and over again.
So about
Now, you can think about maybe what this sum would be, negative 1 plus 1 minus 1 plus 1. What's that do? Super interesting question that we're not going to answer right now. Number 8. It really is.
That was anticlimactic.
Well, we'll have to come back to it. Let's just say you don't know enough to do it. Or you might think you do, because you're like, psh, it's 0.
It doesn't work that way. Math doesn't let you have that satisfaction.
On the board, she put a problem that she told Benji to ask one of the BC kids to solve because she knew we couldn't solve it.
Oh,
I
okay.
was like,
It
no.
was an integral that you couldn't
Oh, and then
There is a way to do it, but BC doesn't need to learn it, and so has it. It's called trig substitution. Number 8. What do you think?
And
Factorial,
factorial.
that's so great. Oh, I hate factorial.
4 over 1.
Is it
So
4
4.
times 3 times 2 times 1?
Is it bottom's
It
gonna
means
win?
that.
But n is 1. The first one times is 1. So 4 over 1 is 4. And then
No, but I'm not gonna win.
What'd you say, Mandy? What do you think it is?
Because that and that one.
3 times 2 times 1.
Yeah.
4 cubed. 4 to the 4th. Wait, let's go to our... Right now we're guessing. Let's go to our grapher. Let's go to our grapher. So then we have 4 to the n. What is it, from 1 to infinity? Oh, come on. Is it still thinking?
Yep.
Okay, stop. Stop thinking. Stop thinking. Thank you. Quit.
And
Okay,
that
y
advice.
equals. Okay, so we have 4 to the n. 4 to the n over n factorial. How do I find factorial again?
It's in the
Math. Yeah, I can do math probability. And then number 4. And then, what's our first one? 4, right? Okay. It's going to think. I think it did like 1, 30, 50, 100, 1,000 or something. Let's see what it comes up with. Hold on, guys. Do you see what's going on here? What's going on here? What's negative 15? Times 10 to the negative 15? What's that? 0.0000015 times, right? How about the 35? Negative 35. 0.00000000000. Why does it say error?
You hit
Because it can't even show me enough zeros. We can go another one if you want besides 100. Let's do like 60 and then maybe like 70. Negative 46. Now it's starting to spaz out because it says I can't do it anymore. Okay, but what's it doing? What's it approaching? 0. Converges to 0. Wait a minute, so who's stronger, 4 to the n or n factorial? N factorial. But does it start off stronger? No. But does it end up stronger? Yes. Weird, right? We can't just trust our minds. This one converges to 0. How about the next one? 6 minus, 2 over n. What's that going to be? 6 minus 2, 4, right? 6 minus 2 over 2, 5. 6 minus 2 over 3. Uh-oh. 5 1/3, yeah, you're right. Right?
Is it converged to 6?
Let's see. 6 minus 2/4, 5 1/2. 6 minus 2/5, what would that be? 5 and
3/5.
6.
seems like 6. Is it 6?
Yes.
I'm sticking with yes.
You want to trust it? We're running out of time. Yes, you're right. It does converge to 6. We'll run out of time. We'll just say yes. Converges. You guys see how calculator can help, right?
Yeah.
Because this one, right? Okay, so we have another way just besides our brains because we cannot just trust our natural logic on this, okay? This one,
4 over 1. 8 over negative 1.
It's negative 2.
what do we have? We have 4. We have negative 8, right? We have 12 over negative 3. Negative 4, right? Yeah, negative 4. What would the next one be? 4 times 4, 16. Over 3 minus 8. 16 over negative 5.
5.
Negative 3. And 1/5. Is that right?
Yeah.
Etc.
Oh, no.
It's all going to be negative from here on out, right? First one positive and then negative, 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 negative. This one's going to keep on getting bigger. This one's going to keep on subtracting. What's it getting closer to? If you go in your calculator, the final answer is, crazily enough, converges to negative 2. Interesting. And strange.
You can use
Unless you just look at the limit and say, psh, limit as I go to infinity,
Yeah.
negative 2. Okay, can we always trust our brains just by looking at sequences? No. We're going to have to pick up this tomorrow because we're almost done, however. This is all the introduction to sequences. Remember, this is not where we're stopping. This is not our end goal. We're just trying to figure out how do terms change, and then we're going to figure out, okay, how does that apply to series? We're going to keep on talking about sequences, sequences, sequences. There are some special converging sequences, like this one that we saw earlier today. It's E. And there are going to be some other special ones as well. But then, at the end of all this crazy... Wait a minute. What do you see now? Ooh, we're going to have to start talking about series, and that's where pretty much the rest of the chapter goes. The rest of the chapter is about series after we get there. So tomorrow, guys, we're going to finish this up. I might actually copy off problems. That way we go faster. But there is a homework assignment. It's not 46. It's something else. What is it, 42? I just looked at it and I forgot. 43?
I think so.
It's already online, so if I were you, I would start page 592. Actually, I don't know. Go up a little ways, just to get a little bit of an introduction in it.
Bye, Missy.
Bye, kiddos. How far should we go up? We should go up to. Probably the 20s. 20s or 30s. Can we go up to?
You see,
Yeah.
I think we can always use limited to
For sequences, yes.
but
Not for series, for
sometimes,
sequences.
except for the constant
Well, like the
it's like
confusing would be.
sine n pi, because that was constant 0.
Right, right. Or like factorial. We can't take rid of a
Yeah, I know.
factorial for L'Hopital's.
Yeah.
But yeah, you're right. On a lot of them we could. And so we'll probably shorten a few things tomorrow with those. Good observation though, kiddo.
Pray that you